Hi, I'm Doug Baldwin. In this video, I'm going to introduce how to define your own functions in Matlab. This is material right at the heart of programming, since in Matlab and most other programming languages, a program is basically a set of programmer-defined functions controlled by a little bit of code that calls them in the right order. There's very little prerequisite knowledge you need in order to understand this video, really just how to do numeric calculations in Matlab using arithmetic and built-in functions. Some acquaintance with function definitions in mathematics would also be helpful, but I'll review that. Now, let's get started. Mathematicians define functions all the time, for example, by writing something like f of x equals x squared plus 1. Such a definition does two important things for purposes of this video. It gives the function a name, in this case f, and it introduces a variable, x here, that it uses to define the value the function calculates. Now we can use this definition to evaluate the function. For example, if we want to know what f of 3 is, we temporarily let x stand for 3 and find the value of the expression on the right side of the equal sign. X squared becomes 3 squared, since x stands for 3, and 3 squared is 9. 9 plus 1 is 10, and so we conclude that f of 3 is 10. Matlab function definitions are wordier than mathematical ones, but they serve the same purposes. For example, here's how to define the x squared plus 1 function in Matlab. To begin defining any function, use the new function command in the new menu. This command opens an editor pane in which to write the function definition and automatically fills that editor pane with a template for the definition. The first part of this template to talk about is at the right end of the first line, or header, where the function's name and variable go. The syntax for this part is exactly as it is in mathematics, namely the name, followed by the variable in parentheses. This variable is sometimes called the function's argument or parameter variable to distinguish it from other variables that might appear in the function definition. We'll see such an other variable in a minute. Following the mathematical example, I'll name this function f and call its argument x. But note that Matlab is much more flexible than standard mathematical notation is about names. A name can be any sequence of letters and digits as long as it doesn't start with a digit, so I could have given this function and variable more elaborate names, but for this example f and x are just fine. Moving to the left across the header of the function template, we get to a place where Matlab syntax differs from mathematics. Matlab functions have a second variable, known as the output or result variable, that programmers use to indicate what value a function produces. That's what output args in the template represents. The example we're working on doesn't dictate an obvious name for the result variable, but I'll call it result as something a little less clunky than output args. The rest of the header is boilerplate that appears in every function definition. In particular, every function definition must begin with the word function. The equal sign and square brackets are punctuation that mark the result variable. And speaking of boilerplate, every function definition should also end with the word end, as here in the template. Skipping the lines with percent signs for a minute, this blank space in the template is where to define the calculation a function does. For this function, that's x squared plus 1. Notice how I use the variable in this expression exactly as I would any other value, and indeed, just like in mathematics, the variable stands for whatever value someone calls the function with. More complicated Matlab functions might do multiple calculations, and so I have to explicitly say that this expression is the one that produces the function's final value. I do this by setting the result variable equal to the expression, by writing the result variable's name and an equal sign to the left of the expression. This statement tells Matlab that variable result now stands for whatever value x squared plus 1 has. Notice that the variable I'm defining, in this case result, has to go on the left of the equal sign, and the value has to go on the right. Before we leave this function, I want to go back to those percent signs. The percent sign introduces a so-called comment in Matlab, i.e. text that explains some code to a person rather than being executed by Matlab. Comments in Matlab begin with a percent sign and continue to the end of the line. Matlab programmers usually put comments that explain how to use a function right after the function's header, but since this function's only reason for being is to demonstrate function definitions, I'll just put in a comment that says that. Finally, I can save my new function and try it out. Matlab stores function definitions in files, with names that consist of the function's name followed by .m. To save this function, I just click on the Save button in the toolbar. Matlab offers to save the function in a properly named file in the current working directory. Both having the right file name and being in the current directory help Matlab find the function later, so don't overrule these suggestions. It's also important to remember to save new or changed functions before you test them, since Matlab never executes function definitions from the editor, only from files. For this function, everything is okay, so I'll finish saving it and move to the command window to try it out. Now that I have defined and saved function f, I can call it just like any other function. For example, I can calculate f of 3 or f of 6. I can use it in larger expressions, such as asking what 2 times f of 10 is, etc. But notice one strange thing about using this function. Every time I called it, its value got displayed twice, once labeled as result and once as ants. This happened because every time Matlab executes a command, it prints the result by default, and calling f executes 2 commands. One is the call itself, whose result is displayed as ants. But inside the function there is another command, namely the one to compute x squared plus 1 and associate the value with result. Executing this also causes Matlab to display a value and to identify it as result. For commands typed in the command window, displaying the result is almost always helpful. But for commands inside functions, it's more likely just annoying. Matlab therefore provides a way to suppress display of a command's output, namely by ending the command with a semicolon. So let's go back to our function and add a semicolon to the line that computes the value, like so. I'll save the modified function and go back to the command window to try it. Now the result only displayed once, corresponding to the command I typed in the command window. In mathematics, single variable functions such as f are only the beginning of what functions can look like. More generally, mathematicians also talk about multivariable functions. For example, if x and y are the coordinates of some point in a Cartesian coordinate system, the distance from that point to the origin is the square root of x squared plus y squared. This relationship can be captured in a distance function d, defined as d of x and y equals the square root of x squared plus y squared. Matlab also allows multivariable functions. To define a multivariable function in Matlab, just list as many argument variables as you need between the parentheses that follow the function name, separating the arguments with commas. For example, I'll define the distance function we just saw by creating another new function in the editor, naming it distance so that the name reminds me what it computes, and giving it 2 arguments x and y. I'll call the result variable d, based on the idea that naming a result variable with an abbreviated form of the function's name can be a good way to remember which variable is the result variable. This function actually does something meaningful, so I'll use the initial comment to describe what it computes. Then I'll fill in the body of the function with the calculation, including a semicolon to suppress gratuitous output, clean up a few empty lines left over from the template, and save the result as distance.m. Now I can go back to the command window and try out the distance function. For instance, I can find that the distance from the origin to point 1, 1 is about 1.4 units, or that the distance to point 3, 4 is 5 units. This is a good place to end this introduction to function definitions in Matlab. There is still more to learn about them, but for now you've seen the essentials and covered a lot of ground. In particular, you've seen what the general structure of a function definition looks like, including the function name, 1 or more argument variables, and a result variable. You've seen how to associate a value computed by the function with the result variable. You've learned about comments as a way to leave notes about what a function does for yourself or other people. And you've learned how to suppress unwanted output by putting a semicolon after a command. I hope you've enjoyed this video, and good luck writing more functions on your own.